Welcome to Spring LIB.
Okay, so let us first start with equation 7b, and that says t equals to twice pi root under m by k. So t equals to 2 pi root under m by k. Now from this equation, if we square on both sides, so this would be t squared is equal to 4 pi squared by k times m. So if you compare this with equation of a straight line, let me write that as the slope as x, okay, plus c, then you can see that, okay, so you can see that this is the equation 1. This shows that equation 1 is straight line, straight line, okay. So from this, how can k be determined on the straight line slope? So if you compare, so the slope would be equal to 4 pi squared by k. Now to determine the k, what we would do is just divide 4 pi squared with the slope. So easy, right? Okay, so what is the line's y-intercept is except today? Obviously, the line's y-intercept is equal to 0 because there is no c part here, the y-intercept part in this equation, right? So c equals to 0. So we have to now plot t squared versus m. So I have plotted this in MS Excel. Okay, so in the y-axis there is t squared, on the x-axis there is m from the given data, and the equation y is equal to 0.1278x plus 0.1388 resembles to the straight line, to the equation of this straight line. Now determine the slope. So from here, so this is part, this was part A. So now for part B, we have plotted and determine the slope. So the slope S is equal to 0.1278, right? So nearly equal to 0.13. This is the slope, and y-intercept, so that is equal to c. It seems to be how much? 0.1388. Okay, so we have done part B of the problem. Now let's move on to part C. Now in part C, show that a non-zero y-intercept can be expected in a plot theoretically if rather than simply using, okay, so we had initially expected from our equation that the y-intercept should be 0, but when we plotted the experimental results, so it showed up y-intercept, right? So this is like a twist, this is a tragedy. So how do we deal with this? So if we consider the mass m to be m plus m naught, so there should be a y-intercept. So let's check it. So let's again start with the equation 7b. So t is equal to 2 pi root under m plus m naught upon k, right? So from this, you can write t squared is equal to 4 pi squared by k times m plus 4 pi squared by k times m naught, right? Now this resembles with y is equal to mx plus c, where m is equal to, so I don't want to use m here because we have already used m for mass, so I will use s for slope and c for intercept. Okay, so in this equation, the slope is 4 pi squared upon k, and the y-intercept is 4 pi squared by k m naught. Okay, so so we need to find out K and m naught from the slope, right? So to find out K, this implies K equals to 4 pi squared by s, pi squared divided by the slope. Now this is equal to 4 pi squared divided by the slope is 0.13. So this gives me the value of K to be 308.9 Newton per meter. So we got K, and the value of m naught. To find out the value of m naught, this is equal to, if you compare these two, so m naught seems to be like what? So m naught seems to be c upon 4 pi square by k. Right now we know everything. So this turns out to be this turns out to be 1.088 kg. We know the value of s, we know the value of k, right? So just plugging those in gives me m naught equal to 1.088 kg. Okay, so we are done with part D of the problem. Let's move on to part D. So what is m naught? So here it's pretty simple, because as in the oscillating system, not only the mass oscillates but also the spring, right? So obviously m naught should be the effective mass of a spring. Okay, so we are done with the solution of this problem. Thank you for watching.